you will learn to find the sum of n terms of some special series. By now, you're familiar with arithmetic progression and geometric progression. The sum of n terms of an AP is equal to n by 2 into 2a plus of n minus 1 into d, or n by 2 into a plus l, where L is the nth term or the last term. It is denoted by S with subscript n. And for a GP having n terms, the sum of the series is equal to NA if R is equal to 1. A into 1 minus R raised to the power of n divided by 1 minus R if R is less than 1. And A into R raised to the power of n minus 1 divided by R minus 1 if R is greater than 1. We shall now find the sum of the first n terms of some special series. Let's first find the sum of the first n natural numbers. Denote the sum of the first n natural numbers by Sn. Let this be equation 1. On rearranging the terms in the sum beginning from the last term, we get the same series again. Denote this by equation 2. Adding both the sides of equation 1 and equation 2, we get 2 times Sn is equal to 1 plus n plus 2 plus n minus 1 plus 3 plus n minus 2 plus and so on up to n minus 1 plus 2 plus n plus 1. This implies 2 times Sn is equal to n plus 1 plus n plus 1 plus so on n times, or 2 times Sn is equal to n into n plus 1. This implies Sn is equal to n into n plus 1 whole divided by 2. Alternatively, the sum of the first n natural numbers can be found by using the formula for the sum of an AP. This series is an AP with the first term 1, last term n, and common difference 1. The sum of n terms is given by n into a plus l whole divided by 2. Or n into n plus 1 whole divided by 2. Hence, the sum of the first n natural numbers is n into n plus 1 whole divided by 2. The sum of the first n terms is denoted by summation of k, where k is from 1 to n. We now consider one example. Let's find the sum of the first 5 natural numbers. Let S5 denote the sum of the first 5 natural numbers. Then, by formula, we have S5 is equal to 5 into 5 plus 1 whole divided by 2. This is equal to 15. Let us now find the sum of the squares of the first n natural numbers. Let us denote the sum of the squares of the first n natural numbers by Sn. Now, we use the identity k cube minus k minus 1 whole cube is equal to 3k square minus 3k plus 1. Denote this by equation 1. Substituting k is equal to 1, 2, 3, and so on up to n. Successively in equation 1, we get 1 cube minus 0 cube is equal to 3 into 1 square minus 3 into 1 plus 1. 2 cube minus 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. 3 cube minus 2 cube is equal to 3 into 3 square minus 3 into 3 plus 1. We get the subsequent terms in a similar fashion. On substituting k is equal to n, we get n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. On adding the respective sides of all the above equations, we get n cube is equal to 3 into the sum of the squares of the first n natural numbers minus 3 into the sum of the first n natural numbers plus n. It implies that 3 into the sum of the squares of the first n natural numbers is equal to n cube plus 3 into the sum of the first n natural numbers minus n. Now, the sum of the squares of the first n natural numbers is Sn. Similarly, the sum of the first n natural numbers is equal to n into n plus 1 whole divided by 2. On simplifying, we get 3 into Sn is equal to 2n cube plus 3n square plus n whole divided by 2. Taking n common in the numerator and simplifying, we get Sn is equal to n into n plus 1 into 2n plus 1 whole divided by 6. Hence, the sum of the squares of the first n natural numbers is n into n plus 1 into 2n plus 1 whole divided by 6. The sum of the squares of the first n natural numbers is denoted by summation of k square, where k is from 1 to n. With the help of this formula, let's find the sum of the squares of the first 10 natural numbers. Let S10 denote the sum of the squares of the first 10 natural numbers. Then, by the formula, we have S10 is equal to 10 into 10 plus 1 into 2 into 10 plus 1 whole divided by 6. This is equal to 385. Let us now find the sum of the cubes of the first n natural numbers. Let us denote the sum of the cubes of the first n natural numbers by Sn. Now, we use the identity k plus 1 whole raised to the power of 4 minus k raised to the power of 4 is equal to 4k cube plus 6k square plus 4k plus 1. Denote this by equation 1. Putting k is equal to 1, 2, 3, and so on, up to n successively in equation 1, we get 2 raised to the power of 4 minus 1 raised to the power of 4 is equal to 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1. Also, 3 raised to the power of 4 minus 2 raised to the power of 4 is equal to 4 into 2 cube plus 6 into 2 square plus 4 into 2 plus 1. And 4 raised to the power of 4 minus 3 raised to the power of 4 is equal to 4 into 3 cube plus 6 into 3 square plus 4 into 3 plus 1. The subsequent terms can be obtained in a similar manner. On substituting k is equal to n, we get n plus 1 whole raised to the power of 4 minus n raised to the power of 4 is equal to 4n cube plus 6n square plus 4n plus 1. On adding the respective sides of all the above equations, we get n plus 1 whole raised to the power of 4 minus 1 raised to the power of 4 is equal to 4 into the sum of the cubes of the first n natural numbers plus 6 into the sum of the squares of first n natural numbers plus 4 into the sum of the first n natural numbers plus n. Now, the sum of the cubes of the first n natural numbers is Sn, and the sum of the squares of the first n natural numbers can be written as summation of k square, k running from 1 to n. Similarly, the sum of the first n natural numbers can be written as summation of k, k running from 1 to n. It implies that 4 into Sn is equal to n plus 1 whole raised to the power of 4 minus 1 raised to the power of 4 minus 6 into summation of k square minus 4 into summation of k minus n. Now, let's substitute the values of the sum of the squares of the first n natural numbers and the sum of the first n natural numbers. On simplifying, we get 4Sn is equal to n raised to the power of 4 plus 2n cube plus n square, or 4Sn is equal to n square into n plus 1 whole square, or Sn is equal to n square into n plus 1 whole square whole divided by 4. This implies Sn is equal to n into n plus 1 divided by 2 whole square. Hence, the sum of the cubes of the first n natural numbers is equal to n into n plus 1 divided by 2 whole square. The sum of the cubes of the first n natural numbers is denoted by summation of k cube, where k is running from 1 to n. With the help of this formula, let's find the sum of the cubes of the first 7 natural numbers. Let S7 denote the sum of the cubes of the first 7 natural numbers. Then, by the formula we have S7 is equal to 7 into 7 plus 1 divided by 2 whole square. This is equal to 784.